Okay, so before we start what we're going to talk about today, let's look back at where we've come from. So if you remember, we talked about solving systems of equations so far in this chapter. And one of the methods that we used to do that was with graphing. And so when we graphed a system of equations, like I did here, we're looking for where's the intersection point. What's the one solution that works in both equations? That's your goal in that situation. Then we did more graphing in the previous lesson where we graphed inequalities. And remember, when we graph an inequality, we're graphing a region looking for the the solution set as a region, not simply just a line. Remember, we had to look to see whether the line was dashed or solid. In this case, it would be a dashed line. And in this case, we would shade below the line. Now, in the previous lesson, we talked about the fact that you always want to use a point not on the line to figure out where the solution set is going to be, whether we shade above the line or below it. So if I put 0, 0, for example, with this one, in this equation, it makes a true statement because 0 would be less than 2. And so we would shade all the points below that line. Now there is a way that we can do this that's a lot faster instead of picking a point not on the line, but it only works when it's in slope-intercept form. So I want to make sure that you recognize this. Before we go any further, make sure you hear me correctly. The only time this shortcut works that I'm going to show you is if it's in slope-intercept form. When it's in slope-intercept form, all you have to do is look at the inequality to see if you shade above or below the line. If it's less than or equal to, we shade below the line. If it's greater than or equal to, you're going to shade above the line. But again, that only works if it's in slope-intercept form. If it's in standard form, you still want to pick a point not on the line. Because I don't want you guys to complain to me after a quiz or a test and say, well, you said if it was less than, you shade below the line. But remember, I'm only saying that if it's in slope-intercept form. If it's in standard form, this trick doesn't work. Okay, so let's take, if I were to take and be able to combine these two images that we have here into one, that's essentially what we're going to be doing today. We're going to be graphing a system, but we're not going to graph a system of equations. We're going to graph a system of inequalities. So the process is similar to what we did over here when we graphed just regular old lines, but we're applying what we talked about yesterday with inequalities. So let's look to see what I mean here. Let's say if we had this example that we were working on. Y is less than or equal to 1/2 x plus 2. So I'm going to start by graphing my y-intercept there, which is a positive 2. My slope is a 1/2, so I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. Now, the key to doing these and getting these accurate is to make sure that we're doing what I just said. You want to make sure that you have an accurate line here. So I put a bunch of points, and that way it makes it easy for me to connect them if I don't have a straight edge. Before I connect them, remember, ask yourself, what kind of line am I using here? It's less than or equal to, so it's going to be a solid line. Next thing you ask yourself from yesterday is, do I shade above or below it? Remember, you can use the point 0, 0, or what I just mentioned, the fact that it's a less than means that we're going to shade below the line. So we would shade everything below the line here. Okay, so now we want to answer the rest of this problem. We want to graph the other equation here. I'm going to do this one in purple. So this one says y is greater than 3x minus 3. So my y-intercept here is going to be a positive 3. My slope for this one, I'm sorry, I looked at that as being a plus 3. My y-intercept is a negative 3. My slope for this one is a positive 3. So I'm going to rise up over 1, rise up over 1, rise up over 1, and so on. If I need to go backwards, I do the opposite. Instead of rising up and going to the right one, I'm going to go down and to the left one. Down and to the left one. And for this one, you would use a dashed line since it's less than, since it's just greater than and not greater than or equal to. Again, it's greater than, so I'm going to shade above the line. Now watch what happens. So this area that's in green here is my solution. Because back up here when we were graphing just a regular set of lines, we were looking at what single point do they have in common. Well, since we're dealing with inequalities, we're dealing with what region do they have in common. And that region we call the feasible region. because that's the region where we would get any feasible or possible answers that would work in both inequalities. Pick anything above this red line, and it would not work in that first inequality, but it would work in the second one. Pick anything down here in the yellow range, in the yellow shaded area, would be one that would work in the second equation. Work in the first equation, but not in the second equation. Pick anything in the green area, and it's going to work in both inequalities. Okay, so that's kind of the big picture of what we're going to talk about today. So let's look more specifically at your notes. Now, as far as my notes are concerned, we're going to change things up a little bit. This is lesson 5-8, but we're going to start at the very end and work our way backwards. So we're going to start with example 2b for this one. Let's start with these bottom two inequalities. Now, with this one, x is greater than or equal to 0. If I had asked you to graph the line x equals 0, you would graph a vertical line going through the x-intercept of 0. But granted, this is an inequality, so that means we would shade everything to the right of the line, everything greater than 0. So essentially what we've just done with this one is we've focused in on quadrants 1 and 4 as being the regions where our answer could come from. But then we have y is greater than or equal to 0. That's going to be a horizontal line going through where y is equal to 0. And the fact that it's greater than or equal to 0 tells me that my solution set is going to be everything above that line. So what I've done with these two is this puts my solution set in quadrant 1. Okay, so I know my feasible region, my final answer, is only going to be in quadrant 1. It's not going to spill over into quadrants 2, 3, or 4. So now let's look at how we would graph this first one up here. Y is less than or equal to negative 1/2 x plus 6. So we go up to 1, 2, 3, 4, 5, 6. Put a point there. My slope is negative 1/2, meaning go down 1 to the right 2, down 1 to the right 2. And again, you want to make sure we do a bunch of points here. So when we go to graph this, it's going to be accurate. Ask yourself before connecting them, do I use a solid or a dashed line? It is less than or equal to, so we're going to use a solid line here. Whoops, close enough. And now we need to ask yourself, would I shade above or below this line? The fact that it's less than or equal to means that I would shade below this line. Remember, the x-axis, the y-axis have already put limits on us to keep us in quadrant 1. So right now my feasible region, if I stopped here, my feasible region would be this triangle. But we're not done yet. We still have the other inequality to do. So this one has a y-intercept of 12, which is way up here, and a slope of negative 2, meaning a down 1, or down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, and so on. And this one also we use a solid line. Now again, my lines here aren't perfect, but this one I would shade. It's also less than or equal to, so I'd shade below this green line. So the area that all four of these have in common is what makes this shape here. My highlighter can't get down and do that little corner, but you get the idea here. So this feasible region is a closed shape, meaning that there's no sides that are left open. And part B asks us to find the vertices. Now a vertex is where two lines intersect. These are the only points where we have lines intersecting at. This one here is just a point. This one here is just a point. They're not vertices. Okay, so don't make that mistake. The vertices are where we have two lines that intersect to form our feasible region. So we have four vertices. Don't overlook 0, 0. And then we have the point 0, 6. We have the point 6, 0. And we have the point 4, 4. All of these are vertices of this feasible region. Let's work on this next one together as well. Because this one, the graph is kind of off. It should have had more on the x-axis down here. But let's actually start with this bottom one. Y is less than or equal to 6. So that would be a horizontal line going through where y is 6. And we would shade everything below that. So that I just need to keep that in mind, that we would shade everything below this one. And for the next one, let's go back up here to the top. Now, y is greater than negative 1/2 x means that there is no that there is a y-intercept, but the y-intercept is at 0. Okay, because you can look at this as being y is greater than negative 1/2 x plus 0. So when we go to do our slope here, it's going to be down 1 to the right 2. Now that ends up running out of space, but I see that it's going to intersect this red line up here somewhere. So I need to extend this out a little bit. So I'm going to go the opposite way. I'm going to go up 1 to the left 2, up 1 to the left 2, up 1 to the left 2. So you get the idea here. We're going to use a dashed line for this one. Okay, next we're going to do the y is, oh, and by the way, for this one here that I just did, the dashed line, it would be everything above that line. So right now my feasible region would be in this space between the purple line and the red line. But now let's draw this other line. Y is less than or equal to 1/2 x plus 4. So my y-intercept is 4. 1, 2, 3, 4. My slope is a positive 1/2, so up 1 over 2, up 1 over 2. Or if I'm going to go backwards, I'd go down 1 and to the left 2, down 1 and to the left 2, down 1 and to the left 2. And this we would use a solid line. And for this one, since it's less than, we would shade below that line. So it's going to be everything below the green line, below the red line, and above the purple line. So in this region is one that all three of these have in common. Again, make sure that you recognize the fact that that goes on over there. Okay, so now what we want to do is we want to find the vertices of my feasible region. Now here's my vertices. I don't have any more. This is not a vertex. This is not a vertex. I don't have two lines intersecting there. Yeah, it intersects my y-axis, but they don't tell me to graph the y or graph x is greater than or equal to 0 or anything like that. So I only have two vertices of my feasible region here. This one's the point negative 1, 2, 3, 4, positive 2. And this one is a point where positive 4, 1, 2, 3, 4, 5, 6. So those are my only two for that one. Okay, so I think you get the general idea here for the first part of this video. In the second part of the video, we're going to look at a couple of story problems and see how inequalities will affect our story problems. So go ahead and watch that next video so you know how to work these problems out.